Chamber heaters in 3D printers have been a hot topic for years. What was once reserved for industrial machines or heavily customized builds is now starting to make its way into consumer printers. The first time I got hands-on experience with an active chamber heater was with a Cheaty machine, and over their last few generations of printers, it's become pretty standard for them. Both my H2C and my H2D from Bambu Lab ship with built-in chamber heaters. I've had plenty of requests to talk about chamber heaters over the years, but I've avoided any sort of DIY solution because if it's not configured correctly, it can be dangerous. Towards the end of last year, Biqu unveiled Panda Breath, an all-in-one chamber heater and filter combo, which is something I was really excited to see. They sent over one of these units for testing, and in today's video, we'll dive into its specs, what the setup process was like, and of course, we'll run some tests. So with all that being said, and without further ado, let's get right into today's video. Before diving into the specs, there's a few things that I want to touch on. One of the arguments I've seen almost every time the topic of chamber heaters comes up for sort of general 3D printing is that it's not necessary, and it just means that you're not using the correct print settings. Well, this certainly can be the case. As someone who has printed a lot of ABS and ASA over the years in printers with chamber heaters and many without chamber heaters, I prefer to have one. For larger prints or trays full of parts, it's great for insurance, and I found it to yield more consistent results without the need for any form of excessive heat soaking. Similar to ABS and ASA, I've also seen the benefits with other materials such as various nylons, polycarbonates, and other high-temp filaments. However, for any lower temp materials such as PLA or PETG, running a heater is a bad idea and will lead to some really nasty clogs due to heat creep. Another added benefit of a chamber heater when printing functional parts is an increase in tensile strength. A couple of years ago, Stefan from CNC Kitchen made a video where he printed ABS parts with these same settings, but in one case he had the doors open, in one he used passive heating from the bed, and in the third case he used an active chamber heater. The parts printed with the chamber heater were nearly 50% stronger, a sizable increase. Let's start by getting Panda Breath unboxed and running through its specs. My first thought when unboxing the heater was, wow, is this thing both larger and heavier than I was expecting. The overall footprint is roughly 176 by 273 by 55 millimeters, and it's largely made up of sheet metal. At the front there is an opening for the PTC heater, one of the fans, and the replaceable filter. There's also an on-off rocker switch and 4 buttons to directly interface with the heater. These buttons let you switch between the 3 different modes: auto, forced on, and filament drying. We'll touch a bit more on these modes a little later in the video. The 4th button is the power off button, and pressing this will disable the heater from running without actually killing the power to the board and the whole unit. Panda Breath uses a 300 watt PTC heater, giving it a maximum chamber temperature of 60 Celsius, and it uses 2 fans to cycle air around the chamber. There's a metal grill that slides up and off so that you can access the filter when it's time to replace it. The filter uses a combination of charcoal and HEPA, which is nice to see, but it is really small, and if you're doing a lot of printing with advanced materials, I don't feel like you'll get anywhere near the 3 to 6 month posted time frame. The replacement filters are available and inexpensive, but if you're serious about filtration, I would look at some of the other larger community filter mods, or even doing something like what I have, which is a large air scrubber for my studio. Before getting this installed, I wanted to take a quick peek inside, so I turned it over and removed the 6 screws holding the back panel in place. On the left side, there are 2 large blower fans set in different directions, both blowing towards the PTC heater to cycle the air around the printer's chamber. There's a curved insert that helps to direct the air outside of the heater, and up top you can see both the chamber filter as well as the controller, which is labeled as Panda Breath V1.0. Since this heater is part of Biqu's Panda series, it is largely targeted for and around Bambu Lab printers. In the case of this heater specifically, in its form factor, it is intended to be sort of a drop-in for the X1 series as well as the P1 series machines. The product page also says compatibility with the A1 series, but given that those are open form factor bed slingers, I think that is a typo because this really doesn't make any sense for those printers. There's also installation instructions for this heater in the Snapmaker U1 tool changer, which is something I would really be interested in if I end up getting a top hat for that printer. They even have mention of support for Voron printers or Klipper printers through a firmware update, but at the time of recording at least, that firmware update has not come, and the only way to control this heater with any printer other than one of the Bambu Lab printers is by manually turning it on or off via the physical buttons or the web app controller. If you have a project that requires parts made in advanced materials, but you don't have the means to produce them yourself, then today's video sponsor PCBWay has you covered. In addition to a decade of experience in PCB prototyping and fabrication, they offer CNC machining, 3D printing, sheet metal fabrication, and injection molding services. Their 3D printing capabilities include everything from FDM, SLA, SLS, and even SLM technologies. I tested out both their nylon SLS as well as their aluminum SLM printing and was blown away with the results, as well as the extremely quick turnaround times. For projects big or small, be sure to check out PCBWay and use the link in the description to get $5 off your first order today. Since my X1 Carbon is completely decked out with various mods as well as a big filter on the inside, I decided to use my P1S with Panda Breath. The installation process is near identical between these two different machines, with the only real difference being the addition of a spacer that you need to print out for the X1 Carbon. The first step is to print out the riser for the top glass panel on the printer. This is needed so that way we have a location that we can route the power cable from the heater to the back of our printer. The riser file is provided by Biqu, and while it does work, I do think it could use a little bit of tweaking. There's some really long overhangs on the inside of the side model that just sagged a bit, and then some of the hexagons, for whatever reasoning, when I sliced them, produced little straggler pieces of filament that I cleaned up most of them, but I can actually see some still on this side. As far as functionality goes, the riser has worked fine. The dovetails, it's all dovetail based, so the pieces slot into each other, and I was actually quite impressed with how solid it felt considering there's no hardware or glue needed to connect all those pieces. Next, I dropped the print bed to the bottom of the machine to give me some clearance for installing the heater and powered off the printer. The unit is held in place inside the printer by slotting into a standoff on the bottom and then being screwed into the frame on the right side. At least for the P series, there's already a screw where we need to install the heater, so make sure that you remove that screw before placing the heater down into the printer. Once you have it in place in the printer, use the included M3 self-tapping screw to secure it to the right side of the frame. The next step is to route the heater's cable up towards the back center of that printed riser. The kit comes with 2 clips with adhesive that I did my best to mirror the photo that was included in the wiki, but even with doing that, I noticed that when the tool head was pushed all the way back as far as it could go, if I moved it to the right, I was able to bump that cable. I don't love this, but I also didn't see any other clear path to route the cable. I did manually jog the tool head with the screen to see if I could get it to bump the cable, and I was able to, but the nozzle is practically off the build plate at that point, so as long as you're not printing edge to edge, it shouldn't be an issue, but it is something that you should at least be mindful of. Panda Breath includes a splitter for the AC cable, so I plugged the power cable into the splitter, then plugged one of the ends into the heater and the other end into the back of the printer. There's also 2 pieces of insulation foam tape that need to get installed on the opposite side of the printer from where you installed the heater. I learned the hard way that if it's not perfectly aligned, you should probably just leave it because the adhesive and foam will just tear. So do your best to make sure you have it aligned where you want it before pressing it in place. With the physical installation done, I powered on the heater. Once powered on, the heater puts out a hotspot that you'll need to connect to. This then guides you through the rest of the setup process, which has you connect it to your local network and then bind it to your printer. As long as your Bamboo Lab printer is on the same network, when scanning, it will locate it and input most of the information for you. The only thing you'll have to grab off the printer itself is the access code that can be found under Settings. The main menu you'll want to look at and potentially configure is the control panel. From here, you can turn the heater on or off, select which mode you want to run it in, and adjust a few settings. With auto mode, the chamber heater will automatically run anytime a job is set to the printer that has your bed temperature set above a certain threshold. The default threshold is 80 Celsius and the default target chamber temperature is 60 Celsius. You can also set a value for the filter fan to run based off of the bed's temperature. The default value for this is 30 Celsius, so basically anytime you are running a job that uses the heated bed, the filter fan will run. In power on mode, the heater is forced on, and it will work to maintain whatever your set or target chamber temperature is. Filament drying mode is used to set filament inside of the printer and use the heater to dry out moisture in that filament. This mode comes with two presets, one for PLA and one for ABS/PETG, along with a third custom one that you can set yourself. With this mode, the chamber will climb to your target temperature and then begin a countdown based off how long you want the heater to dry out your filament before it shuts itself off. With the heater installed and set up, it was time to run some tests. For my first test, I homed the printer, powered on the heater, and checked the hot end thermistor temperature every 15 minutes for an hour. At 15 minutes, the hot end read 35 Celsius, at 30 minutes, 47, and at 45, 55 Celsius. This was near the peak of what it reached, and at the 1 hour mark, it had just jumped up to 57 Celsius. Halfway through the test, I went around and felt on the different panels just to see how warm the printer was, and it was a lot warmer than I was expecting. Specifically, the front left side of the glass, which seemed to be the hottest portion, was hot to the touch. Not burn your hand hot, but it certainly was not comfortable to leave my hand there for long periods of time. Since I ran that first test with just the chamber heater, which is not really a realistic situation you'd run into when printing, I ran the exact same test again, but this time I had the chamber heater running as well as the bed set to 100 Celsius. With this test, at 15 minutes, the hot end read 48 Celsius, and at 30 minutes, we hit 60 Celsius, which was our target temperature. I knew that it had to go quicker considering we had a additional large heating element that was now running, but I was very pleased to see us hit the target temperature in under 30 minutes. Next, I wanted to see what the difference in chamber temperature was from the top to the bottom of the printer. For this, I grabbed my thermocouple thermometer and taped one of the probes just below the center of the top glass panel and another one just above the bottom center plastic panel. I then threw some polycarbonate inside the printer and fired off a print. For the first print, I ran it without the chamber heater and measured once right when the print started with the goal of measuring it again right about halfway through the print, which was approximately 30 minutes. At the start of the print, the bottom of the printer read 30 Celsius and the top of the printer 42 Celsius. With this being polycarbonate, it warped like crazy, and by 43% it had completely come off of the build plate. Before stopping the print, I checked temps one last time, which read 33 Celsius at the bottom and 49 Celsius at the top. The next morning, I fired off the exact same print, but this time with the chamber heater running. At the start of the print, the bottom of the printer read 54 Celsius and the top 53 Celsius, a massive jump compared to our first test. Since our first test failed at 43%, I wanted to take measurements once again at that exact same time frame. At 43%, both the top and bottom read right around 55 Celsius. I closely monitored this print as I did still see some warping that was progressively getting worse, and by 87%, this print also had detached from the build plate. Given the surface area of this print and the fact that I didn't use a brim or any sort of additional adhesive, I was really pleased to see that even just with the same settings and the heater, it held on to the build plate for twice as long. Polycarbonate is not a material that I use on any form of a regular basis, but I figured that it would be a good choice to stress test this heater. While I still need to do a lot more testing with this heater, so far it's really impressed me. The build quality far exceeded my expectations. and it really seems to both bump the temperature of the chamber up quickly and help to maintain even temperature across it. I really hope that we see compatibility or even direct control with Klipper firmware, as I feel like that would really take this heater for a lot of people to the next level. Even with the max target temperature of 60 Celsius, one thing you will need to consider for any printer you're installing this inside of is what electronics are you exposing to those increased temperatures. For a lot of printers, the power supply and controller are typically isolated from the inside of the chamber, but still things like stepper motors or even toolhead boards could benefit from additional heat sinks or additional fans to help pull some of that heat away from them. While I don't see a need for a chamber heater in every single printer that I use, having access to something like this that's sort of an all-in-one that just needs to be dropped in really simplifies the process, and I'm looking forward to seeing how Panda Breath continues to evolve. Personally, I would love to see this in a smaller package, maybe one using the same 300 watt PTC heater, but getting rid of the carbon filter and one of the fans, or maybe using slightly smaller fans, so that way it's just easier to install in a wider range of machines. And that has been the Biqu Panda Breath. I hope that you enjoyed this video and that I was able to answer most of your questions on what it is, what the installation process is like, and how it works. If you do have any additional questions, let me know in the comments and I will do my best to answer. As always, if I don't know the answers to your questions, I have no problem reaching out directly to Biqu to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every week to every other week, so there's always fresh content coming your way. And if you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!